All right, so we're going to start learning about polar coordinates, another way that we can go through and graph different equations that don't necessarily have to be in function notation. So in your rectangular coordinate system, you're dealing with x's and y's, and x is, how far left or right you go, and your y value is how far up or down you go. So this point here is at, it's over 12 and it's up 5 is the coordinates for that point. So you're looking at an x and a y coordinate. This new coordinate system is called polar coordinates, and polar coordinates, instead of dealing with an origin from which you start going left and right and up and down, we're going to look at what's called the pole, which would be the origin. So just like your 0, 0, your pole is sort of your starting point. And then we're going to look at this in terms of a radius and an angle measure. So a radius and an angle measure. So your radius is going to be the distance from the pole that you travel, and then the angle is going to be, from the positive x-axis, or 0 degrees, how far up or down are you moving there. So we're going to talk about something that's called directed distance, and directed distance is from the pole. Are you moving away from the pole in the positive direction, or we'll look in the negative direction as well. So that's how we're going to go through and graph some things. So if you look at this polar graph here, my radius is 13 and the angle measure is about 23 degrees. So you'll have a radius and you'll have a theta instead of an x and a y. And we can convert back and forth between the two, depending on what we need to do with the problem. All right, and I kind of just explain this. So the relationship between the rectangular and the polar coordinates, if I go through and I graph a point that's at 12, 5, over 12 and up 5, that would be rectangular form, an x and a y. In polar form, I'd be concerned with what the measurement for the hypotenuse is, which would be 13. And this angle measurement, I'd have to put this in my calculator, could do inverse tangent of 5 over 12. It's about 23 degrees. So my radius is 13 and my angle is 23. That's my r and my theta. So those 2 points land in that same position, but one's measured in rectangular form, the other one is in polar form. So if we look at the coordinate plane for polar graphing, it looks very different. This is looking, it looks like a bullseye almost. You don't really have like an x-axis and a y-axis, although I will go through and kind of superimpose, here's like my x-axis and my y-axis, because those points, really work hand in hand there. So I still kind of think of those as my x and y-axis. So we're going to go through and plot these points, which are in polar form. We're going to put them in standard position, which means they're starting from the pole and working our way out, either in the positive or the negative direction. Let's do this first one, though. I'm going to put these all into degree mode. So 2 is my radius, pi over 3, 180 divided by 3. That's 60 degrees. Just to sort of get you warmed up with this. This would be, my radius is 3, and negative pi over 6 is negative 30 degrees. And this radius is 3, and 11 pi over 6, that's 330 degrees. Oops, 330 degrees. And then this last one is negative 2, and negative 2 pi over 3 is going to be negative 120 degrees. You don't have to convert those. I just want to do, none of the problems are in degrees, they're all in radians. I just want to do one that's in degrees. So I have graphing paper for you, polar paper, if you want to graph on polar paper. And what you're going to do is you start with your angle measurement. So my first point here, I'm at 2, 60 degrees. So I'm going to, from my pole, my positive x-axis here is 0 degrees. And if I'm going 60 degrees, just like we did when we graphed angles in standard form, 60 degrees is in this positive direction, so 60 is right up here. And my radius is 2, so from the pole, I'm going to move out 2 rings and put a point right on that, I call it the bar, that 60-degree bar there. So this is my first point A. And then if you look at the next one, letter B there, 3, negative 30. So from 0, I'm going to go down. Here's negative 30 degrees in the negative direction there. And from the pole, I'm moving towards that angle measure 3 units, which is my radius there. And then moving on to letter C there. My radius is still 3, but my angle is 330 degrees. So from 0, I'm going to go around 330 degrees, which is on this bar right here, and I'm out 3 rings, which is going to put that point right on top of where point B was. So both of these have the same location. And you're going to find that you'll have an infinite number of points that can land in that same spot or that same location there. And then that last one, letter D, my radius is -2 and my angle is -120. So going in the negative direction, in this direction, -120 is going to put me right here. This would be -90, this would be -180, so -120. And then I need to do a radius of -2, which means instead of heading towards that angle of -120, I'm going to head in the opposite direction, which is going to put that point right here on top of point A. So these 2 points have the same location. And if I'm only going once in the positive or once in the negative direction around that sort of unit circle there, there's 4 ways that you can rewrite a point that will land in the same position but have either a different radius or a different angle measured there. And it would be -2 pi to +2 pi or -360 to +360. So either one of those, going in the positive direction or negative direction. There's 4 different ways that you can name each point. And we'll go through and do a couple where we're naming the points in different ways. Right. I sometimes find this easier if you actually graph this. And, you know, if you want, you can convert this angle measurement into degrees if that makes more sense to you. I'm going to leave this one in radians for now, just so that we can try some in radians as well. Most of the homework problems are radians. So I'm going to plot this angle. So it's -3 pi over 4 is the angle measure. -3 pi over 4 is -120. So there's 0, -pi over 2, -pi. So -3/4 of the way around is going to be on this bar right here. Right? -120 degrees. Or sorry, -135 degrees. So I need to do a radius then of 3. So from my pole, from the center, I'm coming out 3 rings. 1, 2, 3. So that's the point that I'm looking at for A. So I want to name this in 3 different ways here. So one way that I could name this, instead of going my angle in the negative direction, I could go around in the positive direction there. So if I go in the positive direction and name that angle measurement, 225 degrees is 225 degrees in radians is going to be 5 pi over 4. And if I go 5 pi over 4 for my angle measure, the radius, I'm still moving out 3 units. It's still +3 for my radius. All right. Now I need to come up with negative radius. And this, I think, is a little bit trickier here. So I kind of think of it this way. I'll draw this bar, if you will, both in the positive direction and the negative direction there. Right, so if I have a negative radius, instead of going 3 units out in this direction, I want to go 3 units in the opposite direction. So that radius would be a -3, and the angle measure that puts me up here is 45 degrees, or pi over 4. So that's another way that I can name this particular point. Instead of going 3 units out, I'm going 3 units back, but I went to that pi over 4, that 45-degree mark. And then finally, one more way to go through and name this. We could go in this direction and get a negative angle measure. That's almost all the way around. That's 7 pi over 4, which would make me land over here. But I want to go in the negative direction so that I land at this spot here. So my radius would be -3. And we'll do a few of these. They're kind of confusing. If it's easier to convert your angle into degrees first and work in degrees first, you can do that. But then, you know, they'll want the answers in radians. What should happen when you do these problems is you should have 2 points where your radius is positive you should have 2 points where your radius is negative. Your angle measure should be different for every problem there. So I think that looks good. All right, let's look at the next one there. So letter B, I'm going to use the same grid again here. All right, so we have 5 pi over 3. So 5 pi over 3. So 5 pi over 3, that's it's almost 6 pi over 3, which is all the way around. So 5 pi over 3 is going to be down here. That's my angle measure. And my radius is -2. So if I continue this in the opposite direction here, my radius is -2. So that's going to put me right there. So I want to come up with some other angles and radii that put me in that same spot. So if I have an angle measure of, going in the positive direction there, from there to there, 120 degrees, which is 2 pi's over 3, my radius would be +2 to name that point. If I go, let's see, in the negative direction, that angle measure would be -pi over 3. And to land in this opposite spot here, I would be going backwards, so that would be -2. Here's a couple more angles. And then let's come up with one more point. So we did 2 positive angles. Let's do another negative angle. If we went, let's see, if we go from here to here, that's a negative angle. That's going to be, let's see, -4 pi over 3. And my radius would still be +2. So I have 2 angle measures where my radius is positive, 2 angle measures where my radius is negative there. All right, and again, if you want to do them in degrees to start, do the problems in degrees to start. It'll get a little bit easier. All right, the other thing that we're going to look at is how do you convert these points back and forth? Because sometimes you won't want to work in radial mode, you want to, or in polar mode, you want to go to rectangular mode. And vice versa. So you have a few equations, and you can use the equations to convert these things, or I'll show you a different way where you're just graphing them using triangles. So if you think about a right triangle, our hypotenuse is the radius, we'll call that radius. My x value, if I call this y and this x, these equations all come from this right triangle here. So if I looked at the sign for angle theta, that's the opposite over hypotenuse, and in terms of this triangle, the opposite side would be y, the hypotenuse would be r, and then I could solve this for y. I would have r times the sine of theta would equal y, and that's where this equation comes from over here. You could do the same thing for cosine. Cosine for theta would be x over r, so so r times cosine theta would equal my x, and that's where this equation is coming from. And if you keep looking at that same triangle there, the tangent for angle theta would be y over x. That's where this equation is coming from. And then the last one's just your Pythagorean theorem. X squared plus y squared equals the radius squared. So those 4 equations you can use to convert these. Like I said, I typically don't use those. I typically kind of draw these things thinking of that xy axis on top of that polar graph there. So, like I said, you can use the equations. So here's your first method, strictly using those equations above there. That's my r and that's my theta. I know it's in polar form because I have a radius and I have an angle measure of pi. So if I want to go through and write these in terms of x's and y's, I would go through and I would use my formula x equals r cosine theta, and I would use my formula y equals r sine theta. And I plug in what I know. So for the first one here, x equals my r, which is 2, and my angle, which is pi. The cosine at pi, cosine is the x coordinate, which is -1. -2 for that x coordinate. And then the y coordinate comes from this equation here, which would be 2 times the sine of pi, which equals 2 times 0, which is 0. So that's the first way that you could solve that. The other way you can do this, and like I said, this is typically how I'll go through and solve them because this seems so much easier to me. The other way you could do that is you could plot this point. So let's go here and plot this point. Well, pi is over here, and if I come out 2 units, that's 2 comma pi. Well, if I think of this as my x-axis and my y-axis, the coordinates for this point in rectangular form, that radius or that x value would be -2 since it's back behind the y-axis, and up or down, it's not up or down, it's right on the x-axis, so my y-coordinate would be 0, just the same point that we got right here. I find it easier just to draw the, to plot the point in each form and just convert from one to the other. But you can use the formulas if you are a formula kind of person there. All right, the √3 and the pi over 6. Using either method there, I'm going to do the graphing one first. Pi over 6, that's 30 degrees. My radius is the square root of 3. And so I need to come up with measurements for the other sides there. Well, this is a 30, 60, 90 triangle. And the hypotenuse, or the radius, is √3, which means the short leg is going to be half of that. So it's going to be √3 divided by 2. The longer leg that's across from the 60 is going to be that √3 over 2 times √3, which is going to give me 3 over 2. So my coordinates then, the x coordinate is 3 over 2, the y coordinate's √3 over 2, x and y. So by using the graph, you can come up with those values. If you don't like that and you want to use the equations again, you can use the equations. Let's see if I can get some of this out of the way. So if I use the equations back here, then I would have x equals r, which is √3, times cosine of pi over 6. Cosine of 30 degrees is going to be √3 over 2. Multiply, you'll get 3 over 2. Same thing we just got. Y is r sine theta, so √3 times the sine of pi over 6. So pi over 6, the sine would be 1/2. So it gives you √3 over 2. Same thing we got. I just don't like to have to work through the formulas there. All right, we can go the other direction. Convert these things to polar form. They're in rectangular form. So again, I'm going to go through and do this graphically first, but you can certainly go through and use the equations. So this is an x and a y. So if I plot that point, I'm going to be back 1 and up 1. So that's what I'm looking at. So the length for that radius then is going to be the square root of 2. Because it's a 45, 45, 90 triangle. So √2 is my radius. And then my angle measure, we have lots of ways you can name this point. I'm going to name it this way. So that's going to be 135 degrees. Or if I want it in radians, that would be 3 pi over 4. Just by graphing that point there. For the next one here, if we go through and we plot this, 0, 2. That's my x and my y. Oops. So if I think in terms of radius, how far from the pole, it's 2 units up. And my angle measure then from here to here is 90 degrees, or pi over 2. So that's what you're looking at. You can either use the equations or you can graph them, whichever you find to be easier. All right, so you have homework problems then from the textbook that will be due on Monday.